Okay, hi everybody, welcome to this next video. So in this one, all we're going to do is we're going to go through some of the basics that you need to know for your foundation exam. So this is purely for foundation pupils. We're just going to go through all the basics that you need to know to make sure you really smash those first few marks in an exam paper. Okay, there's quite a lot of things to go through, so let's jump straight in. Right, first one, fractions, decimals, percentages. How do you convert a fraction to a percentage? Well, in this case here, we've got 4/20, okay? Now, whenever you get a question like this, and it's asking you to turn it to a percentage, or it could ask you to turn it to a decimal, what you need to do is make the bottom number to 100. So think to yourself, how do you go from 20 to 100? Well, I times by 5. If you multiply the bottom by 5, you times the top by 5 as well. So 4/20, 20 times 5 is 100, so 4 times 5 gives you 20 at the top, and 20/100 therefore becomes 20%, or 0.2 if you're asked to put it as a decimal. Okay, 0.20 is the same as 0.2. If it was something like 5/25, okay, think to yourself, how do you get 25 to 100? You times that by 4, so you times that by 4, and in this case that would also give you 20, which is 0.2. Okay, so that is your first bit there. If you then have a percentage and you're asked to put it as a fraction, well, 12% is 12 out of 100, because remember, percent means out of 100. Okay, so 12% is 12/100, and then if it asks you to simplify it, if it's both even, that becomes 6/50, even again, 3/25, and then there's nothing that goes into both of those. Okay, if you're asked to write that as a decimal, 12%, or 12/100, which is 0.12, because it's the same as dividing by 100. Okay, so there's your first little bit on fractions, decimals, and percentages. Next one, converting units. There's quite a few you need to remember here. Now, the key thing to think about is whenever you see this word kilo, okay, so it can be kilometre or kilogram, that means 1,000, okay? And then you've also got milli, okay, which basically means 1,000 as well. Okay, so with this, that would help you remember a couple of things. And the other one is cent, so centimetre, okay, is 100. So they're kind of three things that should help you a little bit with some of these. Now, let's talk about this. 5,400 metres to kilometre. So 1 kilometre, so 1 kilometre is 1,000 metres, okay? Generally speaking, most of these are 1,000. It's just this one that's 100. So 1 kilometre is 1,000 metres, which means that 1,000 metres is 1 kilometre. Now this is 5,000, so it has to be 5 point something, because it's 5,000, and in this case it's 5.4 kilometres. What you're effectively doing here is dividing this by 1,000 to get 5.4. But if you struggle with that idea of remembering to divide by 1,000, just remember 1,000 is 1 kilometre, 2,000, 2 kilometres. So if it's 5,000, it's got to be 5 point something. Now we're reversing this, and I've now told you the kilometres. Well, it's 4.7. Now I need to times that by 1,000, okay, which becomes 4,700 metres, because we're going from a kilometre to a metre. So you times by 1,000 there. Now, remember, if you're stuck, think about it, it's a 4, so it has to be 1 point something would be 1,000, 2 point something would be 2,000, so 4 point something is 4,000, and then the 0.7 is 700. Next one, we're looking at time, so 200 minutes to hours. Remember, there are 60 minutes in an hour, okay, so not 100, so 120 minutes is 2, so 1 hour, 2 hours, and then 180 is 3 hours. So I know here this is going to be at least 3 hours. And then 180 to 200 is 20 minutes left over. Okay, I know it seems simple, but just be very careful, because I've seen this before in the past where pupils have done this wrong and put 200 minutes as 2 hours. Okay, moving on to the next one. So 320 centimetres to metres. Well, we know that 100 centimetres is 1 metre, 200 would be 2 metres, so 300 means it must be 3 point something, so it's 3.2 metres. Okay, so technically what you're doing there is you're doing 320 divided by 100. Remember, it's 100 now because it's centi. Cent means 100, so it's centimetres to metres. That's going to get smaller because it's 320 is in centimetres, so then reverse it to make it smaller to get it to metres. Okay, so if you want to, you can have a quick pause of the video and then try and answer these four at the bottom there to see if you get your head around it. There's litres, millilitres, kilograms and grams there. Just remember, all of these will be looking at that 1,000 value because milli meaning 1,000, kilo meaning 1,000 as well. So have a go at those if you want to. So 2,500 millilitres becomes 2.5 litres. Remember, 1,000 would be 1, 2,000 would be 2. And obviously where this is between 2 and 3, it's 2 point something. 4.2 litres becomes 4,200 millilitres. So you're multiplying it by 1,000. 8,200 grams becomes 8.2 kilograms. And then 1.7 kilograms becomes 1,700 grams. Now you might get asked a question as basic as that, convert from one thing to another, or it might be part of a worded question. Okay, next thing, moving on. We're going to look here at ordering values, so from smallest to biggest. First thing to identify, this means smallest to biggest. Okay, so if you're asked about ascending order, it starts with small, goes to big. Now, the best way I think to answer this is what you do is you take all the values, so 0.036, you take the next value 0.36, you take the next value 0.0036, next one 0.3, and the next one 0.03, and you line them up on top of each other. What I would then do is make them all so they have the same number of digits by adding zeros in, and just make sure you know which ones you've added zeros to so you don't get yourself confused. From here, what you then need to do is you need to look at the first column. You say to yourself, what is the smallest number? So all of these have a 0, so they're all the same. You then go to the second column and you go in this column, which one is the smallest? So we've got a 0, we've got a 3, so that's not smallest. We've got a 0, we've got a 3, and we've got a 0. So we now look in this column, sorry, this row, and this row all have a 0. So then what you do is you go to the next column. Now, I've got a 3. I'm ignoring this one because I know that in this column here it was a 3, so that's not smallest. So I can effectively, at the moment, just kind of get rid of those two because I'm not looking at those at the moment because they had 3s in that second row. So I've gone smallest, all the same. 0, 0, 0, all the same. Next column, 3, 0, 3. So out of those 3, the smallest one here is this row. Okay, so I then start my process with 0.0036. This one was my smallest one, so I cross it off. Now the ones I put a line through before, I'm going to get rid of those lines, and I'm going to go back to the start again. So this column, 0, 0, I'd ignore this one now, 0, 0, they're all the same. Next column, 0, 3, 3, 0. So I'm looking at this and this now. So again, I can put a line through those two. So I've got 0 and a 0 there. Then I go to the next column here. What's smallest, that or that? Well, they're both the same. So I go to the next column. What's smallest, the 6 or this 0? And because I've got a 0 there that I made up, I know that this is the next smallest one. So it becomes 0.03, and I ignore those two blue zeros. Cross that one off because I've done it now. Go back to the start again. Smallest, 0, 0, 0, all the same. So that, and that all the same. Next column, 0, 3, 3. So that means this one is the next smallest. So I go 0.036, cross it off. Go to the start again. We've got a 0 and a 0. We've got a 3 and a 3. Third column, 6 and 0. So this is the next smallest one, 0.3. Cross that off. And then you're left with the last one, 0.36. So that's a really nice way of making sure you don't make a mistake. If you order them up like that, making sure you don't make a mistake. Okay, next one, order these fractions in ascending. So again, smallest to biggest. When you have fractions, what you need to do is make the bottoms the same. So make the denominator the same. Now, we've got a 4, a 3, an 8, and a 2, and a 12. So we've got 5 different denominators here. Okay. If you're good with your times table, you should be able to figure out what they all go into. Now, 4 and 3 go into 12, 2 goes into 12. So 4, 3, 2 and 12 can all be made the same quite quickly if you wanted to make them to 12, but 8 doesn't go into 12. So what I know is that if I was to do my 4 times table, my 3 times table, my 8 times table, my 2 times table, and my 12 times table, 24 is the magic number. It's the number that they all go into. So what you then do is you think to yourself, how do you make that bottom number to 24? Well, this one needs to be multiplied by 6. Okay, that will make it to 24. So it becomes 6 over 24. So 6 times 1 is 6. 6 times 4 is 24. The next one, I need to make that to 24, so I times it by 8. 2 times 8 is 16. And then 8 times 3, 24. Next one, 8 times 3 gives me 24. So 5 times 3 is 15 over 24. Next one, I need to make the 2 to 24, so I times it by 12, which means I end up with 12 over 24. And then the last one, how do I get 12 to 24? I times it by 2, so it becomes 18 over 24. Now what you can see is they're actually very close to each other. All of these ones are very close, so it'd be quite hard to guess this one. Then what you do is you put your answer down in ascending order. So the smallest one here is this one, 6 over 24. But you don't write 6 over 24, what you write is a quarter. So you write that value there. Then cross it off because you dealt with it. Next one, next smallest, well I've got 16, 15, 12 and 18. So 12 over 24 is the next smallest one, which was a half. So I cross that off. Next one, I'm going up. So 15 over 24, which is 5 over 8. Cross it off. Next one, 16 over 24, which is 2/3. And then the last one, 18 over 24, which is 9 over 12. And that is the best way to order fractions. Okay, so anytime you're asked about ordering fractions or if you're asked to compare, saying which one's bigger, make the bottoms the same. Okay, look at a bit of rounding now. Okay, so rounding to significant figures and decimal places is different. So significant figures is the first number that is not 0. Okay, so what I mean by that is 3 here is the first significant figure. So what you need to do is think about 2 significant figures, 1, 2. Underline the significant figure you're looking at, draw a dotted line after it, and then think to yourself, how does that 5 affect that 8? Now, if it's a 0, a 1, a 2, a 3, or a 4, it will stay the same. If it's a 5, 6, 7, 8, or 9, it pushes it up. Okay. Now, I'm sure a lot of you will be comfortable with that and happy with that idea, but it's just worth writing down and being careful with. So how does that 5 affect that 8? Well, because 5 is here, it pushes it up. So it now becomes 3.9. It's up to you if you want to pause the video here and have a go at these, but I'm going to go through them anyway. So you can either watch or pause. 3 significant figures. So 3 significant figures here is 1, 2, 3. So this 4 is your third significant figure. There's no decimal involved here, but you're still thinking to yourself, how does this 6 affect the 4? Well, the 6 affects a 4 by pushing it up to a 5. So that becomes 375. But because there's no decimal, I still need this value here. This 6 now turns to a 0 because it's before the decimal place. In the previous example here, anything after that second significant figure becomes irrelevant because it's after a decimal place. If it's before a decimal place, you're looking at the third significant figure, then you have to put this in because we still need it as a place value. Okay, it's a little bit more complex to get your head around. Next one, 1 significant figure. So this doesn't count, this doesn't count, and this doesn't count because they are all zeros, which means the first significant figure here is this one. So you do the same thing, underline it, draw a dotted line. How does the 6 affect the 4? It pushes it up. So it now becomes 0.00. You have to keep those because they are before the significant figure, and then that turns to a 5. Okay, and then you don't need the 6 and 8 anymore to be turned to zeros because they become irrelevant because it's all after a decimal place. Okay, now let's look at decimal places. So here, 2 decimal places means we start with the 9. So if it said 2 significant figures, we'd start with 4 because that would be 1, then 2. But because it's decimal places, we look at where the decimal is That's my first decimal place. So 1, 2. So you're underlining the 3 because that's your second decimal place. How does the 6 affect the 3? Well, it pushes it up, so it becomes 3.94. Okay. Next one decimal place. 7. Draw a line after it. How does the 3 affect the 7? Well, it doesn't, okay, because 3 makes it stay the same, so it stays as 12.7. And then the final one, 1, 2, 3 decimal places, sorry. Final one, 1, 2, 3 decimal places. How does the 7 affect the 6? It pushes it up, so it becomes 0.047. Okay, so there are your 3 bits of rounding. Now you could just get a question that is basic rounding, so like as simple as that, so you round it to this decimal places, or it could say as part of an answer, give your answer to 3 significant figures or 2 decimal places, whatever it might be, so make sure you are happy with that process. Okay, next lot of stuff we're going to look at is finding the fraction of an amount. This is relatively simple to get your head round. You just need to remember, divide by the bottom, and then times by the top. A little trick to remember, divide by the bottom, times by the top. So 40 divided by 8 is 5, and then times by the top here is 5, is 25. So 5 eighths of 40 is 25. If you want to pause the video and have a go at this one, you can, or you can just watch. 420 divided by 7. So remember, divide by the bottom, times by the top. 420 divided by 7 is 60, and 60 times 6 is 360. Okay. Now, you could get a very simple question just like the first 2 that I've done there. It could be that easy, or it could be something like this, where you've got telling you about a volume, and then it asks you to work out the fraction of the shape that would be filled up. So a fish tank shown here is filled with 2/3 of water. Work out how much water is in the tank. Now, basically, what you need to do is you need to find the volume, okay? Because if it's filled up with water, that means it's the inside of the shape, so it's the volume. Now, if you're not sure on volume of shapes, there's a previous video I've done about volumes of shapes. It's worth looking at. But I said to you, the first thing you have to do is find the area of the front and then times it by the depth. Well, the area of the front here is 30 times 20. So 30 times 20. If you didn't have a calculator, just do 3 times 2, which is 6, and then add your 2 zeros back on. And then you're doing that times by the depth, and the depth in this case is 10. So you're doing 600 times 10, which gives you 6,000. So we're saying it's 6,000 centimetres cubed. Now 2/3 means all you do is you're saying 2/3 of 6,000. So you divide by the bottom. So you're doing 6,000 divided by 3, which is 2,000. And then you times it by the top, which is 2. So it becomes 4,000 centimetres cubed. On a side note, 1 centimetre cubed is actually equal to 1 milliliter. So you could say that that would be 4,000 millilitres as well. Okay, last couple of bits we're coming to now. Factors, multiples, primes, and squares. Really key things. So factors are facts of a number. What I mean by that is they are numbers that go into it when you do your times table. So factors of 10 are 5 and 2, 1 and 10. Because when you multiply them, they are facts of that number. Multiples get bigger. So a multiple is the times tables. Okay, so multiples of 10 would be 10, 20, 30, 40, 50. Primes, only divisible by itself and 1. So only divisible by itself and 1. Squares, things like 2 times 2, which is 4. So a number multiplied by itself. And a cube is 2 times 2 times 2, which would be 8. Okay, because 2 times 2 is 4, 4 times 2 is 8. So it's you need to understand the difference between each one of those things to help you answer these questions. So it says list all the prime numbers between 20 and 30. So the first thing I would do is write 20, 21, 22, 23, 24, 25, 26, 27. So I'd list all the numbers, and then I'd say to myself, right, prime numbers means it can only be divisible by itself and 1. Any even number can't be a prime then, because they can all be divided by 2. Then you've got to think to yourself about what other numbers go into it. So 21 can be divided by 3 and 7. So that's not a prime. 23, is there anything that goes into 23? No, so that is a prime. 25 can be divided by 5, so that's not a prime. 27, 3 and 9, so that's not a prime. 29, nothing goes into it, so therefore my two answers would be 23 and 29. Okay, be careful, 21 is not a prime and 27 is not a prime. Okay, it's worth knowing your prime numbers. Just think to yourself about the list of prime numbers. 2 is the first prime number, it's the only even prime. Then 3, then 5, then 7. 9 is not a prime because 3 goes into it. 11, 13, 17. Remember, because 15 is not a prime because 5 goes into it. 19, 23, and we've done 29. So they are your first key prime numbers. Okay, write all the factors. So remember, facts of the number are things that multiply to give you it. So start with 1 times 24. Then you've got 2 times by 12. Does 3 go into it? 3 times 8. Does 4 go into it? 4 times 6. Does 5 go into it? No. Does 6 go into it? Yes, we've already done it. So we can now stop, meaning they are all the factors. Okay, so start with 1, then go to 2, then go to 3, then go to 4. And if it doesn't go into it, then just don't write it down. But that's the best way to write it so that you are aware of all the pairs. First 5 multiples of 7. Remember, multiples are in the times table of that number. So 7, add on 7, 14, 21, 28, 35. That's just basically your 7 times tables. And if you don't know it off the top of your head, just keep adding 7. Do it in your fingers, whatever you need to do to get it right. So 1, 2, 3, 4, 5. They are my first 5 multiples of 7. From this list, identify all multiples of 12. So multiples, remember, being numbers that are in the 12 times table. 6 is not a multiple, it is a factor. So that will be put in there to confuse you. Multiples of 12. 12, 24, 36, 48, 60, 72, 84, 98, 96, 108. Okay, they are all your multiples of 12. So no, no, yes, no, no, yes, no. So identify them very clearly. Just don't be caught out with the fact that 6 becomes a factor. All square numbers. So 1 times 1 is 1. 1 is a square number. 2 times 2 is 4. 4 is a square number. 3 times 3 is 9. 9 is a square number. 4 times 4 is 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. So if you don't know your square numbers, write them down. Go through it step by step. So let's look at the list. So we've got 16, which is a prime. 36, which is a prime. And then 8 times 8 would be 64. That's your next square number. So all of those three, sorry, I think I said prime there, I meant square numbers. So they're all your square numbers. Cube numbers, now it's 1 times 1 times 1, which is 1. 2 times 2 times 2, which is 2 times 2 is 4, 4 times 2 is 8. 3 times 3 times 3, 3 times 3 is 9, 9 times 3 is 27. So prime numbers become very big, cube numbers become very big very quickly. 4 times 4 is 16, 16 times 4 is 64. 5 times 5 is 25, 25 times 5 is 125. So these are probably your key ones that you need to be able to remember. So from this list, no, no, yes, no, that's squared, yes, that's cubed, no, and yes. So making sure here, these are all your square numbers, you understand all of these square values here, and then making sure here you understand all these cubed numbers, okay? Okay, last section we're going to look at is just some simplifying with algebraic terms. So simplify basically means collect your like terms. Which ones are the same? So we've got a 5e here, and we've also got an e here. I suggest you circle them so you know that the sign that is in front of it belongs to it. So 5e minus e is you saying 5 minus 1 basically, because that's effectively a 1e. That becomes 4e. It doesn't just become 5. It's not as if you're just getting rid of that e like that. Okay, what you're doing is saying 5 elephants, take away 1 elephant, I've got 4 elephants. Next one, 4f minus 9f, that is a negative 9f. So you're saying it's 4 degrees outside, because it's a plus 4, and you are taking away 9 degrees. So it gets 9 degrees colder, which means you end up with a minus 5 degrees, and then you put your f after it. That's your answer. You cannot simplify that, because 1 is an f and 1 is an e. Okay. Be careful with the next one. This is all multiplication, which means you're saying a to the power of 4. Notice the difference between the next one. That is adding. So this one's here was multiplying. This one is adding. So I've got 1, 2, 3, 4 apples effectively. So that becomes 4a. So notice the difference between those two. Next one, if you get a number and a letter, deal with your numbers first. So 8 times 3 is 24. Then deal with your letters. B times b is just b squared, 24b squared. Notice the difference here. This is 8b plus 3b is 11b. Very different question. Final 3 here then, guys. Same again. So deal with the numbers first. 6 times 2 is 12. So we know it's going to have a 12. And then the rule with indices is when you multiply them, you add the indices. Okay, so x to the power of 3 and x to the power of 5 becomes x to the power of 8, because 5 plus 3 is 8. Y squared, y to the power of 7, is y to the power of 9, because you're adding those powers, okay? When we are dividing, the rule is you subtract. So 8 minus 2 gives you 6. Okay, make sure you don't put 4 there. And the final one, we're combining a few things here. Numbers first, 24 divided by 8 is 3. And now what we're saying is, I'm dividing, remember this line means divide, I'm dividing x to the power of 5 divided by x to the power of 2. Remember what we just did here, if you're dividing you subtract, so you're doing 5 minus 2, which is to the power of 3, and then y to the power of 10, and y to the power of 3 becomes y to the power of 7. If I quickly show you why that works, we're basically saying 24 times x, 2, 3, 4, 5, divided by 8 times x times x. So this is just dealing with the x's. So if I just ignored the y's for a minute and just dealt with that part of this, that's how I've written it here. It's how you could also write it. 24 divided by 8 gives me 3. And then these basically cancel each other out, but they turn, it's x divided by x is just 1, so they cancel each other out. And you're left with 3 there, which is why I've got the 3 there. And the process would be the same with the y's. Okay, there's a lot of information in this video. It's worth going back over it and checking those parts. They are all the key things you need to know to do with your foundation paper and all those fundamental key skills. So do make sure you are happy with it. I hope you found it useful. Thanks for watching.